Okay, the product rule. We've just been doing the power rule. We've done that for a few days. Okay, the product rule is when we have something times something, and we're taking the derivative of two things being multiplied, because product is the answer to multiplication problem, right? So when we're taking the derivative of two terms being multiplied, this is how the product rule goes. U times v prime plus v times u prime. A way to remember that is first d last plus last. Oh, this marker's so big. Try a skinnier one. Okay. First d last plus last d first. It's a way to remember it. U is the first guy, V is the second guy, the last guy. First, D last, D means take the derivative of the last guy. That's why we have U times U prime, plus last, V was the second guy, the last guy, times D first, derivative of the first. First D last plus last D first. Everyone say that. First D last plus last D first.
So the first number times the derivative of the last.
Mm-hmm. Yep, so D last means derivative of the last. D first means timesing by the derivative of the first. Okay, so we have one on number 4. Let's try it. This is your U, and this is your V. Okay, f prime of x, new color, f, and I'm going to do f prime of x because the function originally was f. First, so we just copy first down, 5x to the 4th minus 3x times the d last, that means the derivative of the last. Margarita, what would the derivative of that second term be? Tell me the derivative of v. Yep. Okay, so that's first d last plus last 6x to the negative 2 d first, derivative of the first. Claudia, what's the derivative of the first? Good. First d last minus or plus last d first. Does that part make sense? Okay, now just go through and simplify. Rules of exponents are going to get you if you don't remember your rules of exponents. Distributing that, 5 times the negative 12 would be negative 60. And x to the 4th times x to the negative 3rd power. We're actually just briefly talking about that right here. When dealing with these exponents and the base is the same, they're both x's, and the base is the same. None of you have me for 10th grade, but I sing a song. When dealing with these exponents, the base is the same. When we multiply exponents, we do what with them? Add, multiply, add, multiply, add. Yeah. I have a fun song. It's a song and dance, clapping and snapping. Okay, so 4 plus negative 3 is just 1, right? So I don't have to write that. 1. I can just leave it as an x. Okay, negative 3x times negative 12x cubed. We do negative 3 times negative 12 is a positive 36. And x to the 1st power plus the negative 3. I'm sorry? Oh, I didn't write it. Yeah, it's just x to the 1st power. X to the 1st power times x to the negative 3. 1 minus 3 would just be negative 2. Okay? Plus, distribute that in. 6 times 20. 120. If you add the exponents, negative 2 plus 3 is just x. 6x to the negative 2 times negative 3 is negative 18x to the negative 2. What do you think you do now? We have some like terms. We have some x's. And we have some x to the negative 2's. Okay, if we're going to write this in standard form, we do it in descending power. Largest exponent first, so I would go with this guy first. Negative 60 plus 120 is 60x. And then 36 minus 18, 18. Positive 18 over x squared. Is that right? By putting it in the denominator? You can also do 18 times 1 over x squared. Okay. So, number 5 is another product rule because we can see we have two binomials being multiplied. So this is u, this is v. Okay, with your neighbor, go do the product rule. Firsty last plus lasty first. Firsty last plus lasty first. Good. Looking good. I have these two terms different. Oh, I distributed in a different order. Okay, yes, I have that one. But that I do not have.
Oh, it's 3x.
There you go.
That's why I was like, is this right?
Yep, so far. Okay. Looks like we're doing pretty good. Careful on your arithmetic errors. Come on. Okay, first, last, I put f prime. Please put f prime of x. Don't just start writing x squared minus 3x. Label it f prime of x. So first, x squared minus 3x, d last. So the derivative of the last. 3x squared plus last x cubed minus 4 d first 2x minus 3. Is that good? I think everyone got that. Now when you multiply everything through, you get 3x to the 4th minus 9x cubed plus 2x to the 4th minus 3x cubed minus 8x plus 12. As I was going around, I think we're mostly there. So f prime of x equals, if you find your like terms, 5x to the 4th, negative 9, negative 3 would be negative 12x cubed, negative 8x plus 12. How'd we do? That's actually looking really good when I went through. Okay, the other rule, quotient rule. Now, there's two ways people say this, and even when you go to college and you're still doing calculus or engineering programs, I bet you people will still do the chance to remember these rules. I learned it with Snow White. Other people learned it with lows and highs. I learned it with highs and hoes instead of, because hi-ho, Snow White, hi-ho, we're off to work we go, hi-ho. Okay, so this is how it is with the V's and the U's, and I'll tell you my little chant. Be very careful on your differences between the V's and the U's. V times U prime minus, give the U a little leg there so you can tell the difference. U times V prime over V squared. So I'll give you two different chants to remember that. I-U Hody Hi, because I just learned it as Snow White, hi-ho. Okay. Ho and D, ho D high minus high D ho over ho ho. Remember back in the day when we had ho hos? Those are good. Ding dongs, do they still make those? Or did Hostess completely out? Ho D high minus high D ho over ho ho. Hi ho. Okay. The other version would be, ho is the same thing as low, okay? The other version is low D high minus high D low over, some people say low, other people say low squared over low squared. And same as the last rule, the D means I'm going to take the derivative of the high. The D means I'm going to take the derivative of the low. D. Ho-D high minus high-D ho over ho-ho. In graduate school, I remember talking to my statistics professor, and it had been a few years since I had done calculus. So I was in his room working on some integrals, because we were doing statistics, you have to do calculus too. And I was like, oh, is this the Ho-D high minus high-D ho over ho-ho? And he's like, whatever helps you remember it. He was like, okay, whatever, sure. And it was the quotient rule, which I was doing. I just called it Ho-D high minus high-D ho over ho-ho. So, let's see what that means on number 6. Okay, ho, low, ho and low. It's the low guy. Ho, x plus 2, d high times the derivative of the high. What's the derivative of 1? 0. Minus high, which is 1, times the derivative of the low, which is x plus 2's derivative, 1, over ho-ho, x plus 2 squared. Which is nice, because timesing by 0 cancels out. So I get y prime, and that was a bad example. I'm going to put y prime equals negative 1 over x plus 2 squared. And you don't have to multiply that through. Sometimes leaving factor form is actually even better, because then you can see cancels. This would also be, if you did multiply it through, first you square the first term, square the last one 2, in between the first and last is first and last one's 2.
4s look like
They do. Okay. So let's try number 7. Ho-de hi minus hi-de-ho over ho-ho. Ho is the low. So we put f prime of x equals ho is the low. X squared minus 4. The high, what's the derivative of the high? Ooh, careful. Number 7. Derivative of x plus 1 is 1. Ho d high minus high, which is x plus 1. D ho, what's d ho? Derivative of the low. 2x over ho ho. X squared minus 4. So all of that squared. Ho ho, we have 2 of those. Okay, I will do some work here to simplify. F prime of x equals, times thing by 1 won't change it. X squared minus 4.
Wait, could we just cross out since we have x squared over 4 on the...
Actually, no, because of the subtraction, you can't just cancel those out.
Plus 9.
Okay, now careful, it does say minus. So when you distribute this isn't positive 2x squared, it's negative 2x squared minus 2x. Because both of those will be subtracted. All over, ho-ho, x squared minus 4 squared. Ho-de hi minus hi-de-ho over ho-ho. Do you see any like terms? Yeah, we have some like terms. F prime of x equals, change my color. My highest degree, I have like terms. 1 minus 2 would be negative 1x squared minus 2x minus 4. X squared minus 4 squared. Okay. Any chance that numerator is going to factor to something that cancels out with the denominator? Possibly. You would want to check that, but this is as far as we need to go. Okay, flip it over. Number 8, we have the, we're asked to find the derivative, find dh dx, derivative of h, evaluated at 2. Can I go now?
Yeah, you're good.
Okay. So, we're given all of those guys. F of 2 is 3, f prime of 2 is negative 1, g of 2 is 4, g prime of 2 is 2. So, if h equals f of x times g of x, which rule would we be using to find dh dx? What rule would we be using? Product rule. They're being multiplied, so it's firsty last plus lasty first. Okay, so h prime of x equals first f of x, d last. Isn't d last just g prime of x? Because we don't know what those are yet. We'll be plugging in a minute. Plus last is g of x. D first. Derivative of the first will be f prime of x. Any questions there? Now we have values. We want to evaluate when the derivative is 2. When x is 2. H prime of 2 equals f of 2 times g prime of 2 plus g of 2 times f prime of 2. And it just so happens we actually know all those values. What's f of 2? 3 times g prime of 2 is 2 plus g of 2. 4 times f prime of 2. Negative 1, I'd put that guy in parentheses so I don't confuse it with subtraction. So if we are evaluating at h prime at 2, I get 6 minus 4 is 2. equals, yeah, I would do that. Okay, number 9. Which rule is number 9? Quotient rule. Sing the song. Ho-de hi minus hi-de ho over ho-ho. Okay, so h prime of x equals, ho is the low. Ho-de hi, d high is f prime of x, minus hi, d ho is g prime of x, over ho-ho. That would be g of x squared, and we actually put the square like on the g. And now we actually know values for all of these, so if I'm doing correct notation, you guys have to work on your notation. Some of your homework was looking kind of sad on your notation. F prime of, if I'm plugging in a 2, I should show it. I'm evaluating at h prime at 2. And it tells us g of x is, well, g of 2 would be 4 times f prime of 2 would be negative 1 minus f of x, or f of 2, because we're evaluating at 2, would be what? 3 times g prime of x evaluated at 2. G prime of 2 would be 2 all over g of 2 squared, 4 squared. So we get negative 4 minus 6 over 16 equals negative 10 over 16. So h prime of 2 equals negative 5/8. Okay, I think we'll jump down to number 11 really quick. Just make sure you know how to do that. This is actually like one on the quiz. Given this guy, find the tangent line. Tangent line means we're going to be taking the, if we're finding the tangent line, we have to take the derivative, and parallel tells us the slope. It has to be the same slope to the x-axis. So when we take the derivative, ooh, actually parallel to the x-axis. So the slope is 0. If you're parallel to the x-axis, that's your first thing. So step 1 is identifying the slope. The slope of the tangent line will have to be 0. Okay, second, find f prime of x, because we're working on getting that equation of the tangent line. F prime of x is 2x, what? Minus 1. Okay, now what? Plug in 0 where? For the x's? Okay, we need a point first. We're working on getting the slope.
So you plug in...
We want the slope of the tangent line to be 0. So we're finding which x value has the slope of the tangent line equaling 0. And if you solve for x, add 1, I get 1 equals 2x divided by 2 divided by 2. X equals 1/2. So this is where it is, and then plug in your x, and then you'll have your point. And then you use point slope like you said. And then use point slope, and you're good. Okay. So 3-2 is due next time. This new one, 3-3, bring questions on. Bring your extra credit pancakes too. Remember, I need like video proof or pictures, print out pictures showing you did it. And change your measuring cups to those limits.
Can we not email it to you, or?
Sometimes things in my email I have a hard time seeing. They kind of come and go. So it'd be best if you just printed it out.
All the measuring cups.
Well, if you're using teaspoons,
Everything
yeah,
you use.
yep. put the marking on it.